Hello and welcome back to a new video in my GameEngine video series. In the last video we implemented the basic code to create an instance to the GPU. So basically all the DirectX 12 device, fans, queue and things that we need to get some work on and to start with the SwapChain. In today's video we actually want to now start with the SwapChain. Now how do we create a SwapChain? It's quite simple actually to create a SwapChain. We just gonna get the DXGI factory and we're gonna say create SwapChain for, and we can actually create SwapChain for multiple things for a composition. As I think also some of the new Windows stuff. There's a core window, which is also Windows new UVP and things like that, but what we care is the HWND, the good old window. Now the function takes multiple parameters. The first one is a P device, which for all of the times DirectX was in existence was true that it was a device, but for DirectX 12 it's no longer. On DirectX 12 it's not a device, it's actually the queue. Why is it a queue? Well, because previously there was not such a thing like a queue. There was only like the device, and what we really now need is the queue, because the SwapChain needs to actually work. Let's call it like it is. The SwapChain needs to do work on the GPU to make sure that buffers are swapped and displayed. So we need to do work, and if we just put in a device, it doesn't know where to do the work. It would need to create its own queue, and then you cannot synchronize with it, and it's bad. So in the end, this is a queue, which is my direct queue in there. Okay, next thing is only gonna give us a problem. An HWND. Where is our HWND? We don't have any access to an HWND. Okay, so how can we get access to our HWND? Basically, what we need to do is we need to know our Windows window, because the Windows window is where our HWND is stored. So what I want to need is I want to have a reference to the window. So basically, I want to save myself the window that I am working on. Now this is going to set a lot more things on fire, because now it doesn't no longer work. So I need to have actually something that I can put in here. But what shall I put in there? How can I put a window in there? So what I want to do is I want to actually have this one as a parameter. So what we need to do is we need to define a Windows window in here. There's no way around that. I mean, we could do it maybe also in here, but we need to define a window. Okay, now we have the window ready. Now we can use it. No, we can't, because the window doesn't support this. The Windows window needs to now actually go in and support getting the HWND. That's quite simple. Inline hvnd get window handle, and then we're just going to return the window handle like this, and there we go. Function implemented, exposes the window handle. Native Win32 handle. Okay, so now we have it exposed, and now at least from the DirectX 12 graphics standpoint we are quite happy, right? We can now say window dot get window handle. It's easy. We have now the window handle and we could continue. However, there are different sites that now make problems. This one. We can no longer make unique D312 graphics because we are missing the window. For that, we actually need to have access to that window. And for that, I need to actually go in and do a bit of magic. So what we're going to do is we're going to do a dynamic cast to a Windows window. We're going to dereference the dynamic cast so that we can put it as a parameter. And what I want to do is I want to get the pointer. Simple like that. Now we have a bit of magic done, and now we have the Windows window exposed to the D3D12 graphics. Simple. Nothing too complicated, but that's what we need to do and we need to keep in mind. Okay, so what are the next parameters that we need? We need to have a DXGI SwapChain description 1. Okay, let's do it. DXGI SwapChain description 1. SwapChain description. There we go. So what do we have inside of the SwapChain description? Let's peek inside and let's grab some parameters. Okay, let's take them here. Let's copy them, let's paste them, let's copy them here, and let's use the magic of multi-line editing to make this all come into play. First of all, the width. What's the width of our window? Well, we don't know. Let's ask it. We can ask it, get width, and we can also ask it to get its height. The format is simple, DXGI format RA-G8, B8, A8, unorm. That's the format that we normally use. This means like 8-bit graphics with an alpha channel. The alpha channel, we just use it as an empty channel. You can actually see that there's an alpha mode and this alpha mode, we're going to put to ignore because we don't care about the alpha mode. Okay, so what do we use? Stereo, false, because stereo is not something that we do. Then we have the sample description, which has a count and the quality. For DirectX 12, this will always be, for a SwapChain, always be 1 and 0. If you want to have multi-sample anti-aliasing, then you need to do it manually with functions and queue and everything. But that's the only way to do it in DirectX 12. In DirectX 11, because there was a lot more abstracted away, you could directly say, all right, I want to have like multi-sample anti-aliasing, and now you would have it. But this doesn't work in DirectX 12. So count 1 because we still have one sample, which is the pixel that we draw, and quality 0, which means no gathering of multi-sample anti-aliasing. So what's the buffer usage? DXGI usage, and what we're gonna do is we're gonna use it as, I think, I'm not sure about that one. I think we're gonna use it as a back buffer. Let me quickly look this up because there are two. Yes, no, I don't need to look it up, I remember it. Back buffer. Buffer count, well, it's equal to buffer count. What is the scaling that's going to happen if the sizes doesn't fit? It's going to be stretched. What is the swap effect? So how do we handle it? We're going to discard the buffer. So we have two buffers, and they will be flipped as soon as we present, and the old one can be discarded. This is how we should do it. Then we can define some flags. So DXGI SwapChain flag. And what we do is we allow mode switching, SwapChain flag, allow tiering. These are the two that we should always define on the SwapChain. At least I would recommend defining them always. Allow mode switch allows you to move the SwapChain from being windowed to full screen mode. Borderless windowed is still called windowed, but this would allow your SwapChain to go into full screen later on. You can later on transform it to be full screen, which is something that you should add in this case. And the next parameter that we input with the allow tiering, we basically tell it to also allow to update the buffer without vsyncing. So if you don't want to do vsync, you should allow tiering, and I think for gsync you need to put these. I'm not sure about that. I haven't done like a proper research on gsync programming on gsync and vsync, gsync and freesync, but I think for these you need to kind of like go into tiering and disable vsyncing, and then basically the monitor will listen to the application more or less. Okay, so that's the description. We don't need really more about that. So SwapChain description, that's what we put in here. Next thing that we need is a full screen description. So DXGI SwapChain full screen desk, DXGI SwapChain full screen description, full screen description. This is how I like to call it. And yeah, same story. We're gonna peek in here. We're going to steal all the parameters that we have, and then again with the power of multi-line editing, there we go. Now the refresh rate has a denominator and a numerator, but we don't care about these. We also don't care about these, which is why we put them to unspecified, and scaling we go to stretched, and then we put window to true. Basically what we do as soon as we put window to true, it's more or less, I think, ignoring these parameters. So we just put in some dummy ones. But any case except of the refresh rate, this one is something that you should need to adjust if you're going to go into exclusive full screen mode, because then the GPU will really sync to it. Then you need to put them in there. Scanline ordering in this case should be unspecified. You should never care about scanline ordering these days. I think it's like a console thing, old monitor thing. You should not really care about these days. Scaling basically is what happens if your SwapChain is not the size of your monitor. In this case, it says stretched. If you are developing, you might do not want to put it to stretch, so you can see if there's an issue between your resolution and the actual monitor resolution. But for production, it should always be stretched, because there's also the things that you can do like half resolution rendering, and then it's been stretched to the full resolution, which is still a thing on like GPUs that are not that powerful. You can do it and just render it at a half of the screen resolution, and it's stretched, or like 3/4 of the screen resolution, and then it will be stretched. in our case, we're just going to write a very, very plain and simple description in here. We do not want to restrict it to an output, so I put a null pointer, and then we have an output SwapChain1 pointer. So we need the SwapChain to be in here actually, com pointer, IDXGI, SwapChain1, SwapChain, that's the one that we need, and we can just put it in here. And there you go, we have created our swap chain. Yay, that's quite easy and simple. Now, if we are creating a swap chain, we need to make sure that we take care of it, which also means destroying it and a bit of housekeeping on the swap chain. Destroying the swap chain should happen here. Release. And this should already now give us a swap chain. We are not feeding it, but we have it. It's existing. You don't see it yet, you don't know it yet, but it is in existence. And you should close without any problems, and we should not have any issues. So now we have successfully created a swap chain. However, to actually make use of a swap chain, we need to take a bit of care about what happens. And for that, I want to go into my iGraphics interface, and I want to define two more functions. I want to define a virtual void begin frame, and I want to define a end frame function. With simple functions, begin frame is called before we do drawing, and end frame is called after we've done drawing. Okay, function to be called before any drawing happens. That's simple. Happens. Okay. Function to be called after all drawing happened. Renders and displays. That's basically what it does. It renders it and it displays it. Okay, so these are the two new API calls that we have. We need to integrate them, of course, into our swap chain. So begin frame override and end frame override. Okay, so let's add some implementations for these. Begin frame and end frame. We really don't care yet about begin frame, but end frame is going to be something, because at the end of a frame, what we need to do is we need to present the rendered image. So how can we present the rendered image? Well, swap chain present. That's the function that we call. Sync interval 1 means that we're going to go for vsync, and 0 means no specific flex, which basically means that we are now presenting a frame with vsyncing. And yeah, you don't really see a difference just yet, but yeah, okay, because I don't call the functions. Yeah, fair point. Let's go to my main.cpp. Let's actually call them. So first of all, the window is updated. Then what I need to do is I need to have my GFX. So let's get my GFX in here, engine get dot graphics, and then I can basically say GFX begin frame and GFX dot end frame. And now in between here, we would have our to-do rendering. Okay, so what if I do that now? You're going to notice that our window becomes black because we're now feeding it with a swap chain. Yay! You can still move it. You can see that it's a bit unresponsive. If I hover over there, it's kind of like taking some time to respond. And if I close it, it's also taking a bit. This is currently to be expected, because basically what happens is we are not really doing our work in a good way. I'm not sure if we can maybe fix it now, temporary. We need to fix it anyways better. But I think temporary, if we flush our queue, we might be already able to compensate for that. If I flush my queue, you can see that it now becomes responsive. Basically, what we were doing is we are representing, we are a bit overwhelming our GPU with the frequency of our calls. If I now synchronize a bit in between, there's enough work for the swap chain to be done. And yeah, this just allows me now to be a bit more graceful on the GPU. Okay, I told you that we need to do housekeeping on the swap chain, and exactly that's what we need to do in begin frame. So what we need to do is we need to check if swap chain needs resizing, because this is basically very, very important on how we do that with the resizing. And also what we want to do in the graphics is we want to take care about something called a canvas size, because, well, we now have a window and we have a window size. However, we now have a graphics context, and the graphics context has its own buffer sizes. So we need to get rid of, we need to take care of the canvas. So virtual size t get canvas width and get canvas height. The canvas shall always match the window, but this might not be 100% the case. If we want to later implement some scalings or something like that, or rendering at a higher resolution that our actual window is, to have a bit more better anti-aliasing, to have multi-sample anti-aliasing, or not multi-sample aliasing, it's, I think, how is it called? Super resolution. Super resolution, it's just a different thing there. You can do like custom aliasing, anti-aliasing algorithms, or you do not do any anti-aliasing, or you do anti-aliasing at super resolution and then just scale it down. And there's a lot of stuff that you can do and not do. I think like the game that was most exposed in this was like back in the times where I was like forced to play Rainbow, like from Ubisoft, and I was going into the settings and there was like a lot of options available, but yeah, not talking about that one. Retrieves the drawing canvas width, canvas height. Okay, retrieves, boom, bim bum. Okay, size or width in pixel. So if we do any like scaling, this is going to be now our golden standard for retrieving these informations. Okay, so now if we have this as an API, we of course need to implement that. Size t get canvas width override and height override, and we are going to store that by basically knowing how big the buffers are. Okay, size t m buffer width and m buffer height. Okay, let's put them initially to 0 so that we have some starting value to deal with, and then these functions are just going to be quite simple. M buffer width and m buffer height. Okay, so now how do we take care about these? First of all, we need to take them into account. So what I do in here is I think we can actually do some initialization here. Let's maybe not have it in here. Let's directly initialize them with the right values by saying buffer width is my window get width, and the same just go for the height, but with the get height of the window. Okay, so now we have them properly assigned. Now, of course, we do no longer want to query the window here because we now have our internal members. And is that his height? Yeah, there is some typo. Okay, sure enough, there is that. Okay, there we go. Now the typo is fixed. So that's basically now our new golden standard, and every rendering would go on the graphics. So now we have a window, we have a graphics, and what we now just need to do is we need to make sure that we don't divagate from that. So yeah, basically what I do in my keep-up code in here, so we check if the window is necessary. We're basically gonna get a new width, which is going to be equal to the window get width. And the same goes for the height, get height, so the new height. Okay, so the first thing that we need to check if the, maybe let's not do it like that, let's make it like that here, swap chain resizing. So first thing that we want to check is that if the new width is not equal to the buffered width, or the new height is not equal to the buffer's height. If these one, they are kind of like going out of scale, we need to do resizing. The end of the resizing is going to be that the new width and the new height are going to be applied. Buffer height. So if they divergate, we need to do some resizing and they need to be applied. Now the first thing that we need to do before we can do any resizing is we need to flush our queue depending on how many buffers we have, so that we make sure that all of the work that DXGI has been done, that this work is released. Now the next thing that I need to do basically here is release, retrieve, and a resize in the middle. We do not have release and retrieve yet implemented at all, but we're going to get to implementing these. But I'm just going to put some dummy placeholders in here. And actually, if we go to our main code after we created the swap chain, you can see that the empty placeholder is going to be another retrieve call. And we're going to as well also have a release call in here to spoiler you. Okay, so how do I resize my SwapChain? It's actually quite simple. We just ask our SwapChain to do so. Resize buffers. Just tell it to do it. Okay, we put buffer count to 0. This means don't change the buffers. We need a new width. We need a new height. And we need a DXGI format. DXGI format unknown is what I'm going to put, which basically means keep the old format. I'm not sure. Officially, the documentation says for the SwapChain flags, it's not allowed to put in like 0 and keep them at the old ones. So we actually need to steal our flags from here and put them in there so that they are defined in here. And actually, to be 100% good, we should define these somewhere else, but I don't want to make it too more complicated now, so that we would have like at one point to change them, but I don't think that I will ever change them. Okay, so this is basically how resize buffers work. Currently, if I run this, this should also work. You will not see any difference. This code still works the same, but now if I'm resizing the window, it actually does resize in the background. Maybe we can kind of like provocate that effect, but I would think I would need Inside Graphics. I don't have Inside Graphics installed. Maybe Pix also can see that. I'm not sure, but I think Pix, it's like the graphic debugger from Microsoft. It's not seeing that. Okay, the Affecto application, the launched application. Build, bin, it should be there. That's odd. It's called empty game. Yeah, okay. Sure. Okay. So I think what you can do in Inside Graphics, if I would resize this text would... Okay. Let me quickly pause and install Inside Graphics. Okay, so now we can try it quickly with Inside Graphics. It's already complaining, like, and Inside Graphics is complaining sometimes a lot. And Inside Graphics also has like one specialty that it doesn't like the debugging layer. So let's quickly do a development build here. Actually, the first development build that we have done. And let's maybe, can I copy that path? Yeah, let's copy that path. And then what you can do in Inside Graphics is you can start an activity, you can select the executable. Yeah, sure. So wrong folder. Let's go to build, binary, develop. And then let's select the empty game. Everything else we should keep as is, and then you can launch the frame debugger and hopefully get something. Yeah, I don't care about Steam. And there you go. There you can see that we have now the window and there's some text in here. So you can see that I have 144 FPS, which is exactly the frame rate of my monitor. VSync is being forced off. Sure, but it seems still that I have VSync because it's a frame rate, so there's still some VSync going on. And if I would now scale the window, you can actually see that this text, it scales with it. So you can see the text is quite small, you can no longer read it. And this is because we are not resizing the SwapChain. But if I now go into that, into my code here, and I quickly uncomment that again so that I can resize my SwapChain, I quickly issue another build command, and then we run the same thing again. You're going to note something different. If I now go and scale, you can see initially it gets smaller, 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 but as soon as I release and the buffer is resized, you can see that the text gets bigger again because I resized the SwapChain, and since I have a resized SwapChain, NVIDIA knows that it takes this certain font size and can draw it correctly, and it's not being scaled. Same, of course, goes for the other direction as well. If I scale it up, you can see, not nice, and if I release, boom, there it goes. Has been rescaled. Can do a frame capture here actually, and if I see on the frame capture, you can actually see what happened on the GPU. This is the nice thing with this graphics debugger. You can see, for example, we had a signal, we get a completed value and a present. So this is basically what happened here. We signaled it, and we get the completion value and present it. That's exactly what we've done. We flushed the GPU without any real work to do, which means that we were kind of like having just these two calls, which was already here, the frame 3114. And yeah, there you can see, we get the completed value, it was good, and then we presented our frame, which was taking like a lot of CPU time. So yeah, it's a lot of stuff going on. I think if you make this a bit bigger, you can actually see the work that was done on the GPU. We are not doing any work on the GPU because we are not really doing something on the GPU. And this is quite nice because in the end, what you can see is you can see the whole history of your frame. You're going to have in the end, we're going to have maybe some complicated graphics code and a lot of things, and you're going to see everything that goes on there. You can, for example, even see what happened here during present. You can see that the textures that we're using, the buffers, you can actually take a look at the buffer in terms of the graphical view, how it looks like. You can even take a look at the memory bytes. You can see everything is black because they're not doing anything, surely. and you can really take a look at what happened. You can see the size of the buffer, refresh rate, width and height, and scaling, scanline ordering, everything that we have set it for the swap chain and things like that, like the swap chain flags, the swap effect, windowed mode, output window, buffer count, the usage, everything that we have done in code is reflected here. You can even go to the device, go to the names, check what the device can do, can check actually what the device is capable of. For example, for the feature levels, you can see if they are supported in here. Architectural informations like the node index of the device, which is 0, tile base renderer false, unified memory false, cache coherent UMA. Unified memory architecture would be a notebook GPU. If you would be on a notebook GPU that uses the same RAM, not a dedicated VRAM, you would have it true here. You can see meta commands that are available. For example, copy tensors is a command that's available for DirectX 12 pooling, and things like that are not like that are not supported by default. It's like meta commands should be something that are like applied on top of it. You can see the format support. You can actually see for which support what does the GPU supports. So that's a really good tool if you want to get into know what's going on. For example, R8, G8, B8, A8 UNorm, that's the one that we have, and you can take a look at what is actually supported in here, or even like copy that out of that, because I think it's, you can see, it's not so nice to handle with that, but you could copy what it can do. Multi-sample, render target, cast with a bit layout, display, multi-sample, resolve. There we go. Now we have it nicely displayed. Thanks, NVIDIA, for that. Oh, I cannot go in there. Okay, not too big of a deal, though. So you can basically see what your GPU can do, which can be a really good insight as well. Multi-sampling, for example. Multi-sampling, I told you we cannot do it with the swap chain, but if you would want to do it, you can actually take a look at which render target supported. For example, you can see if you want to go for the UNorm format again, RGBA, this one. You can see like what's supported, like 1.1, 2.1, 4.1, and 8.1 is supported. So like in this case, it's quality level is 1, samples count is that one. I think quality level is always just 0 or 1. If it's 0, it would mean not supported. And you can see like for this texture, we can go to like normal, multi-sample integrated aliasing, which means none. Or I mean, it's still. I'm not sure what 1 actually means, but it's still doing multi-sample anti-aliasing. I would need to look this up actually. But it can do 2, 4, or 8 samples per pixel. So there's a lot of things that it can do. It's quite nice. And Inside Graphics and Pix, both applications, is what I would recommend you getting. If you work with that, get both. I'm not sure if Inside Graphics works without NVIDIA GPUs. Not sure about that. If you're done, you can just click on Terminate and you're finished. Okay, so let's get back to the code and let's talk about the release and retrieve that I was like just magically putting in there. Now, what we have now is we have a swap chain, but we have no way of actually accessing the buffers in the swap chain. In Inside Graphics, you saw the buffer that I showed you. We need to actually access this buffer. And for that, we need to, kind of like gain access to them. And for that, we're going to have an array of COM pointers of ID3D12 resources. And these are going to be my buffers. So let's just call them buffers. And we're going to have them as buffered count. So as many buffers as we have buffers defined. These are the number of buffers that we will have, but we need to have access to these buffers. And if we are rescaling, we need to release access to these buffers. So for that, I'm going to write me private functions. Private, okay, here. So we're going to have a void get buffers, and we're going to have a void release buffers. Since we need to call them multiple times, we need to call get in the constructor, we need to call get release if we resize, and we need to call release in the destructor. I like to make them functions. So as you can see, we can basically now just go in here and say release buffers, and after the resizing, get buffers. That's basically the code that we were missing. And we need to then go in here and call get buffers as well. And down here, after flushing, release buffers. And this allows us to make a really, really simple code. So how does release buffers work? Well, basically for size ti equals 0, I smaller buffer count, I plus plus. I just want to go through and say buffers at I dot release. That's the only thing that I need to do on the release side. The get buffer side is a bit more involving, but it's not too bad. So what I want to do in my buffers is I want to say buffers at position I is going to be equal to something, but I think we are not as easy as that. I actually think I need to call my SwapChain, and I call the get buffer method on the SwapChain. I'm going to give it an index, and I'm going to put an IID PPV args, and now I have the buffers. Okay, so this code is already quite leading us forward to get the buffers. However, that's not everything that we need, because at some point, if you are beginning a frame, you need to draw something. All right, if you want to draw something, you need to set the buffer as a render target. How do you set a render target? So SwapChain resizing is that. And then we're going to have something, prepare render target. So we need to prepare a render target. How do we prepare a render target? We need an ID 3D12 command list. We don't have a command list yet, but we're going to have one at some point. And this command list is going to have functions for the target. So what there is going to be is, okay, no, it's not graphics command list actually, and this has a function called omSetRenderTargets. And the render target that we are setting is basically the render target we want to render to, which is our back buffer. And what this one needs, it needs a pRenderTarget descriptor. And this render target descriptor is basically defined by a D3D12 CPU descriptor handle. And what we also want to do is you want to clear the render target. So before you can render on it, what you want to do is you want to clear the render target view, which also takes a CPU descriptor handle. So you need to have render targets. And render targets is something that we put on the so-called descriptor heap. Okay. So what we need actually is we need, additionally to the buffers, we need to have some informations about the render target. So what we're going to have is ID 3D12 render ID 3D12 descriptor heap is something that we're going to have. mRTV heap. For the render target views, we're going to have a descriptor heap. mRTV heap. Okay, additionally what we're going to have is we're going to have render targets. D3D12 CPU descriptor handles. These are my RTV handles. I'm going to have as many handles as I have buffers. And now we just need to make sure that these are initialized. Okay, so we're going to go up a bit, and before we're going to retrieve RTV and handles and buffers. And before we're doing that, we need to initialize that heap. So mGPU create a descriptor heap. IID PPV args to my RTV heap. Now we just need a descriptor here, and this is the D3D12 descriptor heap desk. D3D12 descriptor heap desk. RTV descriptor heap descriptor. It's a bit redundant, but that's just how it is. And we need to specify this one so that we can specify these. Okay, so what do we have inside? We have a bit of information about what kind of heap we want to do. DirectX 12, you probably know that from my DirectX 12 video series. It has a lot of things going on with descriptor heaps. But in this case, we're going to create a special one. We're going to create them for render target views with buffer count. And we're going to have a no special flag, and the node mask is 0. So that's everything that we need. Descriptor heaps is created. Now we just need to actually fill the handles. So for size ti equals 0, I smaller, buffer count, I plus plus. I think the buffer count, how did we make it? It's an int. Let's make this now a size t. It's better. So that's consistent. Okay, so now we basically need to get these descriptors. So what I'm going to do is D3D12 descriptor, or D3D12 CPU descriptor handle. So that's the descriptor handle, which we're going to do ATV heap start handle, and that should be able to be equal to get CPU descriptor handle for heap start. Okay, so this is basically giving me the information about the heap. And now what we need is we need a few metrics on our device. We have the device here and we need some heap metrics. So I'm going to have a uint64 m RTV heap increment. This is going to indicate how we need to increment a heap in order to get the next descriptor. And this is something that we need to ask our device, and I think I want to have it maybe here. Get heap metrics. So let's retrieve the heap increment metric, which is a call to my GPU device, get descriptor handle increment size. And this is going to be for render target views. We have these for multiple heaps. If we need them for other heaps, we can later on implement them. And what we now need to do is we now need to make sure that we use these to offset the heap start handle. So my RTV handles at position I is going to be equal to mRTV start handle, and there's a pointer inside. And this pointer must be plus equal to I times the mRTV heap increment. So this is basically what we want, and we need to fool DirectX a bit so that we can put this inside of the descriptor. So we take the actual heap and we increment that by the index that we're trying to receive. And now we should have all of the handles. And we should have the heap. We don't really need the heap. We just need at some point, I think, to set it. No, I think for the RTV heap, we don't even need to set it. I'm not sure. I haven't done DirectX in quite a while. But we need it in our getBuffer function, because every time we are getting new buffers, these heap values need to be reinitialized. That's the only thing that's really missing now. So what I want to go is after getBuffers. For every buffer, I need to initialize these. Actually, I think we can ask our buffer to create a view. No, how do we ask it? I think we do ask the GPU, right? GPU device create render target view. Exactly. We ask our device to create a render target view, and if we create a render target view for our buffer, that's the one that we want to do it. We can put null pointer in here because we want to have a default view. And then we just need a handle. So RTV handle, and we put it at position I so that it knows where to put the descriptor at. And that's the only thing that we need to do. Now we have the descriptor there as well. And what we can do inside of our begin frame, prepare render target. So when we're preparing our render target, we need to have a comment list now. This is now really unfortunate because we now need also some comment lists. Maybe let's move this one to our metrics. Let's maybe move the metrics to the top window and debug. These are kind of like, let's maybe do it like that. And then let's do our executional comment list down here. So to create a comment list, we need an ID 3D12 command allocator. So that's a memory allocator used for the comments, and I'm going to call this comment allocator. Okay, like this. And then we're going to have a comment list. So ID 3D12 graphics comment list. So we have now a comment list and we have a comment allocator. And what we need to do is we need to make sure that we use these in the proper way and also to initialize them. Okay, so this is going to be like that. Command execution, and we basically is going to be quite simple. GPU device create a command allocator. We're going to create a command allocator for direct comment lists, and then we're going to do it's for comment allocator in here, so that we have a comment allocator. And then GPU device, we create a command list. We have a node mask of 0. Command list type is a direct command list. The command allocator we want to use is the command allocator. The initial pipeline state is null pointer. We don't use pipeline states just yet. I'm just not gonna take away that magic from you yet. and then we put in the comment list. Okay, so now we have these created. Now we just need to feed them. In begin frame, what we want to do is we want to prepare our render target. Begin frame is where I'm asserting that the comment list is in the right state. So what I'm going to say is clear render target view. This is something you should always do. So you clear it to a certain color. Render target view that we want to clear is the RTV handles, so the render target that we want to use, but we need to have a certain index to that. So let's maybe save these, and let's have a size t, and let's call this active buffer index. This is basically what we want. We're always going to have. No, let's maybe not put it in here. Let's try to. No, we want to abstract it away. So okay. Get active handles. So we want to get everything that's active. Let's call it get active buffer. And so we're gonna say auto buffer index equals SwapChain get okay, that's interesting because I think we are not. Okay, well, hang on. We are not as far enough with our comic here, with our SwapChain. We need to have a bit of more modern SwapChain. Get current buffer. I'm not sure. Is it called get current buffer index? I think it's called get current buffer index. It's a SwapChain 3 that we need. Okay, so let's take a SwapChain 3. And then let's say get current back buffer index. That's a function. However, this is going to ruin our life here because that SwapChain is now no longer compatible. So what we actually need is an DXGI SwapChain 1 in here. SwapChain. We need a temporary SwapChain. I don't really like that this is not using IIDPPV arcs there, which is quite sad. So let's then change the code a bit. So SwapChain, it's defined like this. So what we now want to do is we want to query the interface on the SwapChain. I have a function for that. I'm not sure, can I go without the error code? I should be, otherwise I should just reprogram my thing. So basically what I do is I query interface to my SwapChain. Again, I'm not using any kind of error checking here. Maybe I do at some point. This can blow up and will blow up, but yeah, error handling, if you don't do it, it may just mean application crashes. Okay, so but we can use now this buffer index to get some auto buffers. We can go this one. I don't think that we need a buffer. Maybe we can comment that for now because I don't need that buffer. Or but what I want to do is I want to have an RTV handle, so that I have the active RTV handle, and then I can just play around with this RTV handle around. So now we have the float clear color. So float clear color 4. It's going to be equal to 0, 0, 0, 0. I think there's a default value. If you don't put in the clear color, it's using the default one. NumRects, null pointer, we can put these to 0 because I don't want to use rects in here. What is wrong with the float in const float array? Yeah, it's a wrong float for you. Is that? What's the problem? Expected. Yeah, okay. Sure thing. But that's basically what we do. So we now put some work on the comment list to clear the render target view, and at some point what we're also going to do is set render targets. So render targets is one render target descriptor, which is the RTV handle pointer to get the render target, false and null pointer because we are not doing some depth stenciling yet. This is the very simple way of doing it. And set render targets, set stencil ref, set lens factor, input assembler, we don't need that one. Output merger. Let me quickly think about what we can already set again. I think we can go to the rasterizer because we need to set a viewport. The RS set viewport is dependent on our screen. We need to compose that one as well. Number of viewports 1. I want to actually cache the viewport. D3D12 viewport. And it's related to the window somehow, and we can put the viewport in here. The viewport basically defines how mapping to the window is done. We also have scissor rectangles, but I don't want to implement these ones yet. Maybe we do need to do it, but I think we need one at least. Yeah, I mean, they can be overridden anyways as well. So basically there's multiple stages related to the GPU. And if we take a look at the interface, there are a lot of functions, and some of them operate on the stages on the GPU, like the input assembler or the rasterizer. And we need scissor rectangles, and we need a viewport. So RS, that's important. We need a output merger. These two things are not too important if we don't use them. It's quite interesting that they do not really put them all together. Set index buffer, set vertex buffer as well. Stream output, we don't use that one. Output merger render targets, that's important. Clear render target, we have used that one. I'm just looking if we forgot anything. But I think that's it already. That's the basic things that we need. Just the scissor rectangles that I want to do. D3D12 rect. Full rect. Let's just call it like that quickly. So viewport and full rect. These ones need to be, of course, also initialized. So maybe let's say init viewport and rect. Init viewport and rect shall go into its own function actually. So void setup viewport and rect. This is a function that it's really important to have because we don't want to have any code duplications. It's okay to have it here. And this function is basically called here. That's important. Initially it's called. And every time we resize, we need to call it as well, because if the window is resizes, the bounds needs to be recomputed. Let's quickly do... So, okay, output merger, rasterizer comes before the output merger, so let's keep these in order. Comment list, rs, set scissor rects. We're gonna have one rect at one full rect. So let's initialize the viewport and the rect then. Full rect. This is, I think, a normal rect. Oh no, it's actually a 3-dimensional rect. Okay, so left is going to be 0, right is going to be the canvas. Come on, canvas. You don't... Come on. Buffer. Yeah, sure, I called it buffer. M full rect left and right. So then we have top equals 0. Is 0, and M full rect bottom is going to be the height. Then the full rect front. No, it's just a 2-dimensional rect. Sure. I was a bit hallucinating there, but okay. There we go. Peak definition. The 3D12 viewport. So these are the informations that we need to fill. So let's take them, steal them, and put them in here. So we have the top left X is going to be 0 and 0. Then we need to define the width again and height again. It's really important. Then the minimum depth and the maximum depth. It's actually most of the time it's minimum is 0 and max is 1. It's a bit the other way around, so that it gets like black if it's in the depth. This is how you do it normally. These things just need to be reinitialized. And if they are now set, we are more or less together now. So now basically what happens is that the render target is cleared and that information is set it up properly. Before we can do that, we need to actually do something different. D3D12 resource barrier. We need to address a resource barrier, and we need to do this as a RTV setup barrier. This is a very important resource barrier we need to set. Resource barriers are used to transition the state of resources, and what we basically say is we say the resource barrier type, we're going to have a resource transition, and we're going to have a resource, and yeah, exactly. I was thinking that we need a buffer. So let's just call this back buffer. And then we basically say that we want to change our back buffer. And from our back buffer, we basically gonna set the state before. The state before is the resource state present. That's where our buffer is going to be in before it feeds into the rendering. And then we're going to have the state after. So the state that we want to move it to is the state back buffer. No, render target. That's what we want to go to. Render target, RTV setup barrier, transition, sub resource 0, because we do not use sub resources. And then we just need to specify flags, and we basically say flag none. This is a so-called resource barrier. It looks ugly, but we need to do it. It's really important, and we're going to set the resource barrier on the comment list. So basically this means that the resource is now in the right state, then we can clear it, we can set it, and then later on the further client code can work with that. After we are at end frame, what we need to do is we now need to make sure that the resource is putting back into the right mode. So basically that's exactly what we need. And now you can see that the back buffer is no longer valid. So let's maybe for now copy this over. And then we can use the back buffer to retrieve that. But I think maybe begin frame should, I personally think we should maybe have at least the back buffer index. This is something that we should have implemented some bit different. Let's say uint m current buffer index, and this is the one that we want to talk about, and then we can take the current buffer index here and here, and we assign it there. So now this is a bit more in line with the philosophy. And now we're just going to swap that. So it's going to be render target, and after that it's going to be state present. And then what we need to do is we need to push that on the comment list as well. So resource barrier, current, one barrier, RTV setup barrier, send it RT render target. It should be more RT than RTV because it's not the view. It's just a render target, the actual buffer. Oops, I already have it in there, so let's change it so the actual buffer to make sure that these are in the right state. But now we cannot just flush the queue. We need to actually execute it. So m command list, m command m direct queue. We now need to execute comment lists. One comment list is to be executed. ID 3D12 command list pointer lists. And the list is going to be my command list, just my list in here, lists. Okay, there we go. This is how you execute a command list. So execute commands. And then we can wait. So flushing the queue, make sure to signal them and run them. So execute. Or now here, wait and present. This is really important. The queue needs to really be finished before we can actually present the frame. Execute commands. Okay, so this is basically the state of back buffer that we need to adjust. We have a similar thing here. This is basically now clear back buffer, clear RTV, and prepare for drawing. Preparing the render target here. Okay, so this is basically everything, and if I do not make any mistakes, this should work. Let's see. It doesn't work. Okay, nice. What's the problem? Let's see what the I know what the problem is. I know what the problem is. I forgot something. We should get an information. Removing device without any more nodes. That's not really nice from your DirectX 12 that you are removing my device. Remove device is a really interesting thing. It basically means that the device was removed from application. That's like a hard crash. It's a DirectX hard crash, and present would give you an error code so that your application can actually error out. But the problem is we need to reset command allocator and list. That's really important. Comment allocator, it needs to be, not released, resetted. Resetted after it has been used, and the comment list also needs to be resetted. It needs to be resetted to a new allocator and a new pipeline state. In the end, what you could do is you could reuse that comment allocator. Actually, as soon as you execute the comment list, you could reset the comment list to a new allocator from an allocator pool, because just the allocator needs to persist after the comment list is recorded. The actual comment list is just a object on the CPU side. The comment list is just the CPU side. It fills that allocator, and then as soon as you execute it, the queue makes sure to move that allocator, which is actually containing like the binary instructions, to the GPU. And let's hope this solves the issue. No, it does not solve the issue. What is the problem? Okay, what is the problem? These errors are always like, we're not in debug. Sure. If I'm not in debug, I don't get any debug informations. So now that's what I'm talking about. That is what I'm talking about. If you have any issues, that's your friend, these messages. Comment list needs to be closed for execution. True. Yeah, that's the thing. Comment list dot close. Close. Bam. Boom. Like that. Let's see. Does that solve our issue? Yes, it does. Closing the comment list. We now have a black window, and yeah, basically we do not have anything more than we had previously. But well, let's take a look inside graphics. Let's do a build though. That's important. Develop, build, and done. And now we can launch the frame debugger to actually see what's going on. And you're going to see that there's a lot more going on now, or you should see that there's a lot more going on. Let's do a frame capture here, and boom. Okay, now we are going. Basically, previously we had nothing, or like these few commands in here. Now we have a lot. You can actually see that we have a reset of the command allocator. You have the reset of the queue, you get the current back buffer index, then the comment list was recorded and it's closed. You can actually not see what was recorded because it's just on the CPU side, the GPU debugger is not going to see that. And then basically what happens is the execute, and as soon as the execute happens, then you can see how the comment list is now played back. And as soon as it played back at the end, we're going to get to that in a second, you can see that we then have our signal, get completed value, then we even get our set event on completion, which means that we now actually had more work to do. So it was not completed instantly, so we had a signal, get completed value. The get completed value, it was 191, but we expected 292, so well, we set our event on completion with the event handle, and then at some point the event was signaled, and then the preset was called. So that's basically what happened now. But on the GPU side, there's a lot of more happening now. You can see the resource barrier, you can actually see where we are doing that. Resource barrier, do we get anything more information about the actual barrier? No, because the resource barrier, as it seems, is not available in the API descriptor, but we might be lucky and get more information in here. Do I get them more? I just get like a ... which I don't like. Can I copy that toggle? Blah. Yeah, I could maybe expand this. But yeah, in the end, what you can see, this is our resource barrier, which is ended with another resource barrier because this was the first and the last comment. Then we had the clear render target view. You can actually see the clear color that's used in here, the descriptor index, that there's no rect used for clearing. The texture that we were actually clearing is displayed here. And you can actually see what happened. Descriptor heap, you can actually take a look at the descriptor heap. Inside redirected CPU handles. Yeah, that's a bit bad. I think this is the actual descriptor heap that we were using. So you can see this descriptor heap 1 here, number of descriptors 2 of type RTV, but you do not get any insights on that heap because the descriptor heap, it's you cannot really go and see it because it's an RTV heap. Later, if we have more inside heaps, then we get more information. But you can see that our device is here, our fence is here, our swap chain. They changed a lot of stuff in here because we now have also the swap chain. There's a lot of information now in here. That's really cool. Yeah, so a lot of things going on. That's nice. But yeah, what you can see that we cleared our render target view, we set it viewport, so you can actually take a look at, no? I mean, yeah, you can, if I hover over that, you can see that there are details in there. I'm a bit sad that it doesn't show them in here. Yeah. Set scissor rects render target. So basically what you can see is that we have a whole replay of our Ah, no, there, event details. This is what I was looking for. The event details tab. There it is. Ah, I'm an idiot. Resource barrier. There you go. Here, we are going for the transition from common to render target. We are setting the viewport. We have the resolution in here. We have depth in here. We set the scissor X. There are our dimensions in here. We set the render target. Yeah, we see the handle. We see the information in here. We have the resource barrier. From render target back to state common, which present is actually state common, but yeah, there's an alias in there that makes it nicer to see in the code. Okay, yeah, I did not see that. But we already have a bit of things that we can play a bit around. No, I didn't want to close them, sorry. We can play a bit around. Actually, what we can do is we can make our screen red. If we are doing all that work, we want to at least see something. Yay, it works. We see something red. We have now a red cleared screen. That's cool. That's not something that we want, of course, but at least we can see that we have done some work. Right? It's nice that you can at least see something if you have written something. And yeah, I've written a lot of code today for nothing. In the end, we have done nothing more, but we have done a lot of work that we actually need. So yeah, thank you for watching. Make sure to like and subscribe. See you in the next video. Have fun. Until then, bye.